Alright, so yesterday we had a pretty interesting Claude Code update that may change the way that many of you fundamentally use Claude Code and may also unlock some new workflows for you. And this is a brand new task management system that includes new capabilities like dependency tracking, and I'll be going over that in this video and what it means for you. But before getting started, this video is sponsored by myself and my Claude Code Masterclass. If you want to join hundreds of other people and become the most proficient Claude Code user at your company through the most comprehensive Claude Code class that you will find online, then there will be a link down below in the description. Okay, so I'll explain the background, some examples, and what you can now do with this new task management system. So getting started, one of the biggest problems of coding agents these days is this agent amnesia that it has, where basically if you start a brand new session in the middle of a task because the context window filled up too much or something, then the agent would forget where it was and then have to rediscover a lot of files unless you write the remaining to-dos in a brand new file. This can get quite annoying and cumbersome to write the remaining tasks into a brand new file and then load it up in a brand new context window, which is why many people developed solutions such as Beads, which is a pretty popular one for many coding agents, where basically it writes everything that it's done so far into a JSON file. It writes a goal that it's currently working on and then the next steps that it has, which means that you can start brand new sessions pretty easily and have one session isolated to completing one task. Another problem that coding agents do have these days is that if they notice a bug or a problem, because the context window is already pretty full or it has like 90, 100,000 tokens in the context window, then even if it finds a bug, it might just drop it and completely ignore that task. But by having each task that you give a coding agent isolated into its own context window, you can now give it the ability to log any bugs for later or tasks that it does come across. Now, essentially what the Claude Code team did is they made this possible, and they said themselves that they were inspired by the Beads repository over here. So basically, Beads is kind of now integrated into Claude Code. And what this practically means is that previously Claude Code had a to-do list, and you may have noticed this when Claude Code was executing. It would just be ticking off things as it goes along. And this was stored in session memory and did not persist across different sessions. So what Claude Code have now done is they got rid of the to-do list, and they now added a task list instead that is saved onto your computer in the .claude folder. So for example, if I go to my .claude folder, go to tasks, then I can see some tasks over here from an earlier session. So I have task number 1, 2, 3, 4, and if I open up any of these tasks, then I can see the description of the task that Claude Code gave it. And I can see a few more things here, such as this task blocks these other tasks and is blocked by this other task. So essentially we have some dependencies here, which means that we can have many tasks running in parallel reliably, knowing that some tasks have to be completed before other ones. But now, since the to-do list itself is stored on the file system instead for each individual session, we can now share it across the different sessions, and each subagent that is actually completing each individual task. So task number 1 is completed by subagent 1, task number 2 will be completed by subagent 2. Each subagent now has the ability to see which tasks there are, which ones are remaining, and to even write new tasks as well. So you can see that in Claude Code, both the main session and subagents have access to 4 new tools. So task create, task get, task update, and task list, which means that a subagent, if it notices that it should create a brand new task to be completed by another subagent, then it can create it right over here. Now this makes Claude Code more useful for longer projects across many different sessions and subagents. So you could have 2 sessions, each with different subagents, all sharing the same set of tasks that they have to complete. Now let's go for a short example. So in my application HyperWhisper, I recently added the ability to stream text as you're speaking onto your computer. And I want to add 11 labs as a provider because currently I have deepgram. So I basically go Claude Code to explore the codebase and write this plan file over here for the changes that should be made. Or looking through this plan, can you basically turn it into a set of tasks that you should complete? And now you can see it's created 6 tasks, and now it's identifying task dependencies, and it identified which tasks are blocked by which other ones. So for example, task 3 depends on 2, task 5 depends on 1, 2, and 4. So we have these dependencies here, and these tasks have now been written into this file with the folder name being the session ID. And instead of waiting, I'll go for a different chat where I've actually completed that plan. One thing I forgot to mention is that you have to specify completed by different subagents because sometimes it just doesn't launch it in a different subagent and it decides to complete those tasks within the main chat instead. We had a dependency breakdown and some of them could be run in parallel because they have no other dependencies. So we had wave 1 where 3 of them ran in parallel, wave 2, and then a final wave 3. And you can see that by the end of the plan, we've only used 18% of the context window. But in this particular case, where we did not specify to have each task run by a different subagent, you can see that this chat basically, like, all the tasks happened within the same context window, and it ended up using about 56% of the context window instead. So yeah, do try to tell it to complete each task with different subagents, and it should automatically identify which one should happen in parallel. Because I find that this new task system sometimes runs them in parallel with subagents and sometimes doesn't. Now, the thing that we just saw now is that instead of Claude Code completing all the tasks in a single session, if we spin it up into different subagents to actually complete it, we get a brand new context window where I can basically focus on completing that particular task without worrying about previous merge conflicts or mergeability problems, because each task does have a dependency. So if you do remember Ralph Wiggum, it's kind of like Ralph Wiggum as well, because each task has been completed in its own brand new fresh context window. And this now mirrors real engineering workflows where you have work being done in parallel, you have handoffs, blockers, and dependencies. But unlike the real Ralph Wiggum bash loop, we still have an orchestra in this case, which is slowly like eating into our context window because it's still like receiving the output of each of the subagents as they're completing the tasks. And a nice benefit that we do have here is that we can tell Claude Code to tell each subagent to update the task list with any new tasks that do need to be made, or we could tell Claude Code to tell any relevant subagent that is completing the task that if anything comes up that the next task has to be aware of, then you should update that task with that information. Okay, now let's talk about how you can have two different sessions of Claude Code, session A and B, sharing the same context. So previously, if you had two different sessions of Claude Code running, for example, one on the left and one on the right in the same folder, then it was pretty tricky to have task updates from one session being broadcasted into the other session. And some people did get around this by using polling within Claude Code. So they tell one session of Claude Code to look at a file every 30 seconds to make sure that any tasks that have been marked as completed are now known to be completed. But you would still have a stale view of the task status for about 30 seconds or whatever the polling interval is. But now what happens with Claude Code is that as tasks are being completed, if two sessions are working on the same task list, then each session is notified immediately when the task is marked as completed or updated in any way, which means that you no longer have the stale information problem, or you won't have two sessions of Claude Code that accidentally start the same task on the task list. So let's actually see this in action. Currently, both of these sessions of Claude Code, even though they are in the same folder, are not sharing the same task list. So to be able to do that, we have to define the task list at the very top. And that would be done by writing in something like this. So I have the task list ID here, which I set to localization, and then I have Claude being triggered after that. So that's basically an environment variable that's being passed in. If I press int on both, and then tell it to convert a file that I have into a task list, then on the left-hand side, we have about 15 tasks that are newly created, and those tasks now appear on the right-hand side, even though I did not put in any prompts on the right-hand side. And whenever it updates with the state, such as which task is blocking which task, then it's also updated on the right-hand side. Can you execute each task in its own subagent? And that will spawn up a general purpose subagent for each of the tasks. But if I did have many different subagent types in my project, then I could specify a different subagent for each type of task if I wanted to. And now as it's completing the task, so number 1 is being completed, you can see it's being updated on the right-hand side. And now you're probably thinking, what am I going to get this right-hand side like Claude Code session to do if the left-hand side is completing all the tasks? And one thing that you can get it to do is basically be a monitor of sorts. You could have the second session of Claude Code being a checker. So instead of creating any tasks, it can monitor which tasks have been completed. Every 30 seconds, it spawns up a checker subagent of sorts, checks whether it's been implemented correctly. If it has, then it can just sleep for another 30 seconds. If it hasn't, then it adds a brand new task to task list for anything that is missing. So I can do that over here. So basically say, every 5 seconds, can you look at the task list to see which tasks have been completed, and then spawn up a checker subagent to make sure the task has been completed according to its description. And if it hasn't, then add another task to the task list to basically complete the implementation in a way that would fit the requirements of the task. So it's like, okay, found 5 tasks, let me get the details and spawn checker subagents that will verify each task. And each of these subagents do have access to the task get tool, so they can actually view each task. And now it's like, okay, all 5 of them have been completed. And then it sleeps for about 5 seconds. It looks that there are 2 new tasks and adds verifying them. So I think this is one interesting workflow that you can have by having two sessions of Claude Code sharing the same task list. I'm sure that many people will be thinking of new workflows in the future. Now, you may actually want to have a more complicated checker, so it's doing something like code simplification or identifying security vulnerabilities as the orchestra is actually like executing on each task. Or you could have the checker session of Claude Code spawn up a headless version of Codex CLI or Gemini CLI or something to do the checking instead. So this is the first idea that came to mind when I was experimenting with this feature. And if any more ideas come to mind, then I will be sharing them in my Claude Code Masterclass. There's a link down below. Now, it is worth bearing in mind that the default value for the task list ID will always be the session ID, which means that if you don't define your task list ID and then do /clear, for example, that will start a brand new session and your task list will disappear even if there were remaining tasks in it. So what you can do is you can put this in your settings.json file, kind of like this. So at the very bottom, you have a end of the section, put in Claude Code task list ID and then your project's name. And this basically means that if you run Claude within the project, then it will always remember any tasks that are being completed, have been completed, until basically all of them are completed, and then Claude Code will delete all the tasks. So yeah, maybe this will be a pretty good long-term workflow. So overall, it is pretty interesting because the Anthropic team looks at any popular packages online and then integrates a version of that into Claude Code itself. But of course, if you do want more flexibility, then beads may be a better solution for you.